Now with a barrel, you can actually do the math and calculate. If I'm going to put in, a certain amount of water per minute and a certain amount per minute leaks out, when will I reach equilibrium and where? That can all be calculated, with a little bit of math. And with the atmosphere, they said, well, when would the atmosphere reach equilibrium? So the guys who invented carbon dating in the late 40s said, I wonder about this Earth's atmosphere reaching equilibrium. They did a bunch of studies on that and said, now if we took a brand new planet Earth, created it from scratch, poof, got it going around the sun, how long would it take to reach this equilibrium point in the atmosphere where the production rate and the destruction rate is the same? And they determined it would take about 30,000 years to reach equilibrium. I'm not sure how they did all that. You could probably see some of the rate scientists and figured it out. But then they made two mistakes, in my totally unbiased opinion. They said, number one, we know the Earth is millions of years old. Mistake number one. Number two, they said we can ignore the equilibrium problem because we would have passed that point 30,000 years ago. They've discovered the Earth has still not reached equilibrium. Radiocarbon is still forming 30 to 40% faster than it's decaying. Now think about that. If radiocarbon is still forming faster than it's decaying, that means the Earth is less than 30,000 years old, number one. And number two, you can't carbon date anything. Because you'd have to know when it lived so that you could calculate when it lived. You would have to already know when it lived to figure how much carbon-14 was it breathing at that time. Doesn't work. There's a website, www.archi.org. He's got more stuff on the Earth has not reached equilibrium. If you want some articles there by Ron Cooper. But this is a calibration curve. If an animal is still alive, it should give you about 16 clicks on your Geiger counter per minute per gram. If you're only getting 8, you say it's been through 1 half-life, or 4 clicks, or it's been through 2 half-lives, or 3 half-lives, etc. This is called a calibration curve. In theory, it sounds like it should work, but there are several real obvious assumptions, and I don't know how they don't see it. Suppose you walked into a room, and I said, I want you to tell me, here's this candle burning on a table. When was it lit? Find out it's 7 inches tall. I said, well, that won't tell me anything. Now we've got to measure how fast it's burning. We measure the candle for a while. We get an Olympic stopwatch, and we get it down to the nearest 40 bazillionths of a second. Okay? And we all agree the candle is burning an inch an hour. Here's our two facts. 7 inches tall, burning an inch an hour. When was it lit? Mary, can't figure it out? Nobody can figure it out. Unless you make some assumptions. Assumption number one, how tall was the candle? And assumption number two, has it always burned at the same rate? Neither of those can be known. If you find a fossil in the dirt, the amount of carbon can be measured, the rate of decay can be determined. I don't argue with either of those. How much was in it when it lived? I don't know. Has it always decayed at the same rate? I don't know. Has it been contaminated, sitting there in the ground for all these millions of years? There's no way to know those things. If the Earth had a canopy of water above the atmosphere, or a canopy of ice, as we cover on Seminar 2, that would have blocked out a lot of radiation from the sun, which would have prevented most of the carbon-14 from even forming. So animals that lived before the flood would have lived in a world with much less carbon-14 to begin with, maybe none, but certainly less. And when we dig up the fossil that's been buried for 4,400 years, let's say it started with 4, where today we start with 16. We dig it up 4,400 years after the flood and say, wow, here's a mammoth that got buried, and it's carbon dated. Well, we're assuming it started at 16. When we test it and find it's got 2, we're going to say, oh, it's been through 4 half-lives, when it's actually only been through 1 half-life, which is why it never works. When they first invented carbon dating, 1949, Willard Libby, they did some testing, and they said the lower leg of a mammoth was 15,000 years old, but the skin was 21,000. How can two parts of the same animal be different ages? Quite obviously, we know one of the numbers is wrong. So how would you know either of them are right? And if either one's right, how would you know which one? I see no way to tell. Well, let's see if it's getting better. 14 years later, they tested a living mollusk, a clam, and it was 2,300 years old. Still alive. In 1970, at the Nobel Symposium, they said, if a carbon date supports our theories, we put it in the main text. If it does not entirely contradict them, we put it in a footnote. If it's completely out of date, we just drop it. You mean they can pick and choose any numbers they want? Exactly correct. If the number doesn't fit what they expected, they throw the number out. 1971. Freshly killed seal was 1,300 years old when they carbon dated it. Troubles with carbon dating are undeniably deep and serious. Despite 35 years of technological refinement and better understanding, the underlying assumptions have been strongly challenged and warnings are out that radiocarbon dating may soon find itself in a crisis situation. Continuing use of the method depends on a fix-it-as-we-go approach, allowing for contamination here, fractionation there, and calibration wherever possible. It should be no surprise then that fully half the dates are rejected. Did you follow that? Out of thousands of carbon dates that have been carbon dating times that they've done it, half of the numbers are thrown out. How do they know they're wrong? And also, how would you know the other half is right? If half your test results have to be thrown out, it ought to raise red flags in somebody's brain. Wait a minute. This is stupid. What are we doing? We're wasting our time here. And the article goes on to say, the wonder is, surely, that the remaining half have come to be accepted. No matter how useful it is, the radiocarbon method is still not capable of yielding accurate and reliable results. There are gross discrepancies, the chronology is uneven and relative, and the accepted dates are actually selected dates. This whole blessed thing is nothing but 13th century alchemy. And I agree. That's 1981. I've got all these in chronological order. It never gets better. 1984, living snails carbon dated 27,000 years old. 1992, two mammoths found side by side. They carbon date them. One is 22,000, the other is 16,000. Which one's right? Or are both of them wrong? Or are both of them right? There is no possible way to tell. In 1996, Carl Swisher at Berkeley University used the most advanced techniques to date human fossils. It says last spring he was reevaluating Homo erectus skulls found in Java in the 1930s. He was testing the sediment found with them. The species was supposed to be extinct for 250,000 years. Swisher used two different dating methods. He kept making the same startling find. The bones are 53,000 years at most, and possibly no more than 27,000. Well, I'd like to point out two things here. He's looking for 250,000 as his answer, but he keeps getting 53 to 27,000, okay, which is only 1/4 of what he wants, 1/5 of what he wants, okay? But he's still getting a 96% error. I mean, is it 27,000 or 53,000? This is not an exact science. So when they publish an article in the paper and say, we found a dinosaur bone or a mammoth bone, and it was, 17,221 years old in 6 months and 3 days. Right, come on. You don't know that. They're making up this stuff, just absolutely making it up. Professor Rainer Prach von Zeiten, earlier this February of 2005, was resigned from a professor because he'd been lying about carbon dating for years. His frauds were exposed in February of 2005. He had dated the Bishkopf spire skeleton at 21,300 years old, but when they tested him at Oxford, they said it's only 3,300 years old. 700% error. He had said, Professor Prach had said he had found the oldest German, the first German to ever move to Germany, 27,400 years old. They tested it at Oxford and said, this is an old man that died in 1750. He's 250 years old. The professor had been lying about this stuff for decades, and so he finally resigned in disgrace. Well, he should, okay? One part of a mammoth dated 29,000 years old. Another part was 44,000. You talk about a slow birth. That would be it, okay? I like this article from Rand McNally. The last 2 years, an absolute date was obtained for the Gandong beds above the Trinil beds. That's in Indonesia. It has the interesting value of 300,000 years, plus or minus 300,000 years. Boy, they nailed that one right on the head, didn't they? Plus or minus, 300% error. In the Geological Survey Professional Paper 862, and I get some flack over this, but I've got the paper in the library somewhere. We couldn't find it here. There's all kinds of articles about carbon dating things in Alaska. I just want to show you a few things here. They carbon dated sample number SI-454. See that on the map there, on the chart there? And said it was 17,210 years, plus or minus 500. Then they tested sample SI-455 and said it's 24,140 years old. Well, 17,000, 24,000, say, wow, that's working good, until you find out that's the same sample as 454. Very same sample.